Okay, so in this section, we're going to take a look at what are known as partial fraction decomposition. Now, let's start off with a more common problem that we've probably seen before. Is, let's say I wanted to add these two rational functions. All right, something we've probably throughout our math career have done before. Right, so the idea here is we have rational functions or some fraction, right? So we want a common denominator. So the first thing we want to see is, all right, well, we have, these are already factored. So we have two linear factors in the denominator. So the common denominator here is going to be just the product of both of those linear factors. All right, x minus 4x plus 2. All right, so we multiply this one by x plus 2 since that's the factor that's missing. And this one by x minus 4, x minus 4. Right, so we would go ahead, right, now we can write it as one fraction here where we'll have 3x plus 2 plus 4, x minus 4. All right, and we get 3x. Then from here, it's just a matter of simplification. Right, plus 6 plus 4x minus 16 all over x minus 4, x plus 2. And here, right, 7x combining like terms minus 10 is equal to x minus 4, x plus 2. Right, so here a problem that we've probably done before. Right, so now, so what we're going to do in this section is we're actually going to do the reverse, right? We're actually going to start off, right? So what if instead of going in this direction, instead what if we had the rational function here, x minus 4, x plus 2, right? So when we have that, so we'll start with a problem like this, and then we'll ask ourselves, oh, can I break it down, right, into a sum where we have two terms. One of them will have a factor of x minus 4, and one of them will have a factor of x plus 2, right? And here we'll, here we see that, well, this can be done. I just did the reverse, so I know I can theoretically, right, this should be able to break down, right? And we'll go over techniques of how to go about doing that, right? But this is what is a partial fraction decomposition. So partial fraction decomposition. Where we're going to go with a rational function, and then we'll break it down into in this case, a sum of its, here we have two linear terms, and we're going to take a look at different cases throughout the section. All right. What's going to be very important here is whenever the polynomial looks like the rational function looks like to begin with, we want to be able to factor it completely, right, to factors that are irreducible, right, or we won't be able to factor any further, right, and we'll stick to linear factors and excuse me, and irreducible quadratic terms, right? Quadratic factors that cannot be broken down any further. All right, and we'll take a look at the process, right, that each one of those represents, and how to go about finding this linear partial fraction decomposition. All right, so one thing that we are going to see is that this partial fraction decomposition is unique. Will be unique. It will be unique for when the rational function has rational coefficients, which we will be working with strictly in this section. And one other thing, in order for this to be able to be broken down into partial fractions, the degree of the numerator must always be less than the degree of the denominator. All right, that would make this possible, right? Now, if it isn't, well, that means that we can actually perform some long division so that we can actually write it in the remainder form where we do have the degree of the numerator to be less than the degree of the denominator, right? So that is a thing we can do when this condition is not met, right? We can actually perform the division. Okay, so as we kind of gear towards the different cases, we're going to take a look at the most basic case, which is the one that I've showcased here, is where we have linear factors that are not repeated. Right? And then we'll look at what if we do have repeated factors? What if it was x plus 2 squared to begin with? Okay, and then we'll look at irreducible quadratic forms, right? And what happens when those are repeated, right? And the different types of techniques that we take to do the decomposition. One thing that's going to come in handy is we are going to be doing, what we'll notice here is we are going to be doing a lot of solving by systems of equations. So we will be using that topic here that we've covered previously to help us in this partial fraction decomposition.